Hello, everyone. You are welcome to today's lesson. And today's lesson is going to be in two parts. The first part, we are going to look at the solution to the assignment that was given in the previous lesson, and that was lesson 5. So, lesson 5 assignment, okay, I'm going to walk you through the solution. We will mark together. Okay, because you can see marks attached to the steps in the solution on your screens. Okay, so quickly, let's start with the first part, the solution to the assignment. And this was the assignment. You were asked to simplify, or you were asked to simplify this. And I told you in the previous lesson that usually you'll be told without using tables or calculators. Okay, but if you don't see that and you see only simplify, it still means, once it's a subjective question, it still means you shouldn't use a calculator, okay, in getting your answer straight away. So please take notes. All right, so at this point, the first thing that you write is solution. Okay, this one, okay, if you want to write this question, fine. But I don't want to see the question. I am only interested in the solution. In any case, I have the question. Okay, so at this point, the first thing that you write is solution. You read the question and you can see that there is nothing, okay, special or salient for you to underline. Any time an expression is given, you simplify. You'll be asked to either simplify or evaluate. Okay, so it is not out of order. Okay, question. So now let's move on. You extract what you are giving. So giving this straight away, you can choose not to write the given, but this must be extracted. So you extract that straight away. Okay, so that will give you your B1. And okay, those of you, I'm addressing a particular concern, who wrote this given on top of the solution. So you wrote given, then you came to write solution, then you started with equal to, you are doomed. In any case, it means whatever that you have on top of your solution is not part of your solution. So you will lose this B mark. Take notes. And again, you cannot straight away start your solution with equal to. What is equal to? So you need to extract whatever that you are dealing with, which is an expression, and a major, okay, information that I'm trying to, or concern. Okay, remember this is an expression. So once I'm dealing with an expression, my steps, anytime I'm working on the given expression, it means it is a step. Okay, I will have an input. So that will be equal to this an expression. So I start my first step with equal to. So if you didn't write equal to and you wrote implication, as some of you did, marking is so easy at this point. So it will be M0, A0. So you are done marking. Okay, so you give us your maximum attention. You are not going to mark. Those of you who did that, you are through with the marking. If you use implication to introduce your first step and any other step, take notes. Is my point well made, my professors? Okay, great. So at this point, the very first step from the previous lesson, I said, anytime you are asked to simplify any log, okay, expression, check whether the log expression contains more than a log term. Okay, and if you have that, write all the log terms as a single log, which is what we did in the previous lesson, the lesson 5. Okay, so if I am going to write this as a single log term, then I have to make sure the coefficient of each log term is either +1 or -1. So if I look at this one, the coefficient is +1. If I look at this one, the coefficient is -2. So it means this one is not satisfying. This one is +1. So I have to work on this. But I've told you, once you are going to work on the terms that will have the coefficient not 1 or -1, work on the fractions, okay, that you can also reduce. So in that case, you can see that this is what I did. Okay, so given this, I came to this. Okay, this one is of the form that I want. The coefficient is 1. But the fraction here, I can reduce. Take note. So this fraction is reduced to this. Then this one, the coefficient is not 1. I will move the coefficient, okay, up here because the coefficient was a power, then it came down. You know this rule. And the fraction here is already reduced, so I won't work on the fraction, but rather bring the power up. This one, the coefficient is 1. The fraction here, okay, cannot be reduced. So you keep it just as you have it over there. And once you do that, M2. Okay, so now the next step, equal to. This is also a step. Okay, you are going to work on your previous step. So that becomes another step. Okay, so your next step, what do? You come and deal with the powers. So this term will be left intact. Okay, this term you have to work on it because the power is not 1. So that will give you 5 squared over 9 squared, which will give you 25 over 81. Then this one is also kept intact, so that will give you m1. Now at this point, you are in a comfortable lead. Comfortable lead in the sense that you can write your log expression now as a single log. So if I have this, okay, coefficient plus 1 minus 1 plus 1. So the form that I want, that was the purpose anyway, okay, to write this as a single log. And we said anytime you have log terms and immediately you realize that there is one negative log term, it means the number that you are taking log of is a fraction. So every fraction will have a numerator and a denominator. Okay, so at this point, I'll write log my common base 10. Okay, then I will come and draw my bar, okay, to separate the numerator and the denominator after realizing that I have a negative term. In that case, I will have a numerator and a denominator. Okay, so if I draw, my numerator will be occupied by all the log terms, okay, the number that I'm finding log of, with the coefficient being positive. So this has a coefficient of positive 1. This also has a coefficient of positive 1. So it means these two numbers that I'm taking log of with the positive coefficients, okay, they will occupy the numerator, but they will multiply in the numerators. So you are going to get this one times this occupying the numerator. Over your denominator will be occupied by, okay, this number, the one with the coefficient of what's negative. And that's this 25 over 81 now becomes by denominator of the fraction. So if you do that, that will give you m2. Okay, at this point, you know, okay, simplify the numerator and the denominator if possible before you come and change this bar. So I use my calculator. You can use your calculator at this point or even do it mentally. The 2 can go here, okay, which will be 50. 50 times what do you call it? 15, or better still, like I said, just use your calculator. Nobody will know. This one, nobody will know if you simplify. So your calculator gives you your numerator as 250 over 81. All over your denominator cannot be reduced, so you keep it intact. So now you know that you can change this division bar to the division symbol. So you are, in fact, you are going to get 250 over 81 divided by, using the division symbol, 25 over 81. But you are matured. You know that the division symbol, you can change it to the multiplication and invert your result. So if you did that as a step, it will not attract any marks because you can do it mentally. Then you change the division to the multiplication and you invert. And that's what I have here. After that, you know, you come and simplify this one as well. So I said you can use your calculator to simplify only this without the log to the base 10. And that will give you 10. In any case, you know that 81 will cancel 81. 25 will go into 250, 10. Okay, and you get, okay, 10 here. Because it will be 10 over 1, then what? 1 over 1. So you get what? 10. So you are going to get log to the base 10 of 10. Okay, and you know log to the base a of a. It's a property that we should all know without the use of a calculator. So those of you who ended here, this will be where your mark will end, even if you had your conclusion drawn. Because your conclusion drawn should be drawn with the value of what? Of 1. Because this we know should give us 1. Okay, however, please take notes. Okay, I remember I told you, when you are writing your log expression, be very careful, especially you writing in lines. So assuming I have this to be my lines. If I'm writing log to the base 10, I'll write my log. You should know anytime you are writing, you write on the line. Your base shouldn't, okay, have even shared this line. Your base should be just below the line. Okay, I told you it is the position that will make the base a base, not its size. So if you write your base this way, 10, on this, please desist. You can see that it shouldn't, whenever you are writing, you have to make sure that if possible, you don't write in the line. So it should come just below the line. It shouldn't even be on top like small on the, no, it should not. It is not the size. Write it just below the line. So henceforth, okay, if you write your expression and do the very first assignment, okay, you realize that some of you, it was costly, it cost you. Okay, the number that you are taking log of, you wrote it as a base. Immediately you do that, you've changed the expression altogether. So let's say if I have log, okay, x cube. Okay, this is the mean. So if you are writing, you have line and you are writing it, it will be log. Your base is 10, it's not written. Okay, this x here is not a base, so it's supposed to be on the line, just as you were writing this. Then your cube here is a power, then you write cube, just as you are writing x cube on a line. Okay, so if you come and write it this way, please take note. If you come and write it this way, log, then this you write x, then you write cube here. Then it means the x is rather a base, but the x here is not a base. So what you've written here is not what you were given. So you are writing your own stuff. I've told you in maths, whatever that you write possibly will carry a meaning. So check whether what you have there will carry the intended meaning across. Otherwise, please, okay, let it reflect what the situation that you want to put across. Please take note. So it is a base. Your base should be just below the line. Okay, just below the line. And the number 75, okay, over 10 here. Okay, at the normal circumstance, most of us, okay, when you are writing a fraction, you use 2 lines to represent a fraction. So maybe if I have 2 over 3, you write over 3 this way, 2 over 3. Most of us, that's what we do. I equally do that. But just as you are advised in the previous lesson, in this situation, if you were not going to get a denominator, which is also a fraction, or even if the denominator will not be a fraction, or it will be an integer, once you are going to get a denominator, please take note. You have a fraction numerator and a fraction denominator. Once you are going to do that, the advice is to write your fraction, okay, in a line. So, you know, sometimes some of you write, okay, use 1 line for a fraction. So in this case, it will be 2 over 5. So those of who usually do that, this will be your comfort zone where it will be, okay, good for you to do so. So in this case, I'm going to write log to the base 10 of my fraction here is 75 over what? Over 10. So I'll write 75 over 10 this way. Okay, or if you like, you know, at this point you are not writing, you won't get another denominator. So you can still write it. Please listen attentively. Okay, I've given you all the clues, all the ways that you can, okay, put across whatever expression that you want to write there. So if I have log, and I know if I'm moving on, assuming I want to write this, okay, this will be log to the base 10. Then I know I'll write 75 over what? Over 10. Is allowed. That's how you are supposed to. So you can still use your 2 lines. But because I know that here I'm not going to write another division, another bar. Okay, it is at this point that you write another bar. So at that point, the advice is don't use 2 fractions. Other than that, if you use 2, sorry, I should say don't use 2 lines for a fraction. Other than that, you are going to use 4 lines, okay, for 2 fractions, 1 in the numerator and 1 in the denominator. So meaning you use 2 lines for the numerator fraction and 2 lines for the denominator fraction. At this point, you, okay, desist from doing that. You avoid that. Your numerator fraction, use as a line. Your denominator fraction, use also a line, so that you get 2 lines in all. Other than that, if let's say I have 4 lines, assuming, I'm just assuming, you use the first line for your first 2 for your first fraction, and you are coming to write this over, then write your second fraction. You will see that the fraction here will be hanging. So what you write there will not be pretty. I don't know if you get my point. Please, do you get my point?
Yes, please.
Okay, so take note. How you write your log expression in your lines is equally very vital, very important. Okay, so at that point, if the explanation to the solution is well taken, okay, aside, okay, from the ways that you are supposed to indicate your expression, your log expressions when you are dealing with lines. I'm not dealing with lines, so I'm comfortable, but you'll be writing in lines, so that's why I have to guide you to do the writing. Any questions before I bring the curtains down on this particular, okay, solution to the assignment? The lesson 5 assignment. Is everyone fine? Okay, very good. All right. So on that note, okay, I am bringing down the curtains. Okay, so thanks very much. Thank you very much for your attention. Okay, God bless us all.